Today we're looking at lesson 6.6 for geometry. This is trapezoids and kites. So there's a few theorems introduced here. This one is for an isosceles trapezoid. So a trapezoid by itself is just a quadrilateral with exactly one pair of parallel sides. We call the sides that are parallel the bases, and then the non-parallel sides are called the legs. And then you have the base angles. And in an isosceles trapezoid, the legs are congruent also. So if you have a trapezoid that's isosceles, each pair of base angles is congruent. And then if a trapezoid has one pair of congruent base angles, then you can say that it is an isosceles trapezoid. And then if it's a trapezoid is isosceles, if and only if its diagonals are also congruent. So we're going to use some of these theorems here in the next examples. So the first example here, so it tells us here that to save space at a square table, cafeteria trays often incorporate trapezoids into their design. So if you have trapezoid WXYZ here, it's an isosceles trapezoid, and it tells us that angle YZW is 45. So YZW, which is going to be this one, is 45. And then it tells us that WV is 15. And that VY is 10. So with that information, we have the measure of angle XWZ to find. And since XWZ is the other base angle, it's going to be congruent to the 45. So XWZ is going to be 45 as well. Then angle WXY is going to be the top angle here. And it is not necessarily congruent to the bottom, but it is supplementary to the bottom. So we're going to take 45, subtract it from 180, and we're going to get 135 for that angle, so here. Then we have XZ, which is the entire diagonal. It gives us both parts of the other diagonal, which is 15 and 10, so if we add those up, that gives us 25, so XZ is going to be 25. And then XV is going to be part of the diagonal, and that's going to equal 10 based on VY, because it's the top part of the trapezoid. So that's also 10. Then we have another example where it gives us coordinates. So here we have the quadrilateral QRST with vertices listed, and we're supposed to show that this is a trapezoid and also tell me whether it's an isosceles trapezoid or not. So we're going to graph them. We have Q is -8, -4. So -8, -4 is going to be down here. Then we have 0, 8. That's R. Then 6, 8. S. And T, negative 6, negative 10. T. So it may not look by the picture that it might be a trapezoid, but we're going to test it anyway. So the thing that you should probably test to be a trapezoid is the one pair of parallel sides. So I would do the slopes maybe of QR and ST. So Q and R, you have negative 8, negative 4, and 0, 8. So that's going to give us our slope, so negative 4 minus 8, and negative 8 minus 0 gives us negative 12 over negative 8, which is, if you simplify it, it's going to be 3 over 2 positive. And then we'll do the slope of TS, which is 6, 8, and negative 6, negative 10. So 8 minus negative 10 and 6 minus negative 6. That gives us 18 over 12, which we can simplify to be also 3 over 2. So we know that it's a trapezoid because it does have one pair of parallel sides. So RQ is parallel to ST. Now we need to determine whether it's isosceles or not. And the best way to do this on a graph is, since we can't really tell what the angles are or find them specifically, we can't really use theorem 6.21 or 6.22, but theorem 6.23 says it's isosceles if and only if its diagonals are congruent. So we can find the distance of the diagonals and compare that. So the diagonals would be QS and RT. So if we get the points of them, QS, negative 8, negative 4, 6, 8. And then RT, 0, 8, and negative 6, negative 10. We're going to compare these two distances using the distance formula. So negative 8 minus 6 squared plus negative 4 minus 8 squared. We get negative 14 squared plus negative 12 squared. That gives us 196 plus 144 is the square root of 340. We'll do that again with these 2 points, so 0 minus negative 6 squared, and 8 minus negative 10 squared. That gives us 6 squared plus 18 squared, 36 plus 324, which gives us a square root of 360. So since that is not going to be the same as the square root of 340, we can say no, it is not isosceles, but it is a trapezoid by definition. So the next one is talking about the mid-segment of a trapezoid, that theorem, which is listed here. And that says the mid-segment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. So we're going to do an example of the mid-segment. So this gives us a picture of trapezoid ABCD, shown to the right. If FG is parallel to AD, what is the x-coordinate of point G? So if they're going to be parallel, that means they have to have the same slope. So I would find the slope of AD first, which you have 0, 8, and 1, 4. So subtract your y's over your x's. You get 4 over -1 or -4. And then in order to find your slope for your second one, you're going to need -4 as the answer. So I would do do the y's first. 8 minus what? And 9 minus what is going to give us -4. So we have to have 4 over 1. One of them has to be negative. So we need to figure out what it could be. Now, you can also kind of look at the graph to get a better estimate. And it looks like it's at about 11 for your x. So maybe you could do 9 minus 11, which gives you -2, actually. So if we did that, that would make the top part have to be looks like it's at about 2 for the y. So 8 minus 2 gives me 6, so that's not correct. So let's try some different numbers here. So now, if we had a graph that was not already done for us, I would say we would actually do 0 as the x-coordinate, because that's the only way to get -4 and be parallel. But the other way to do it is actually to look at the mid-segment theorem, which tells you that the two bases added together divided by 2 is your mid-segment. So we do have the lengths of the two bases that we can find. So if we use the distance formula for AD, let's try it a different way. We have 0, 8, and 1, 4. Let's find the distance of that. That's the square root of 17. And then the distance of BC. Is the square root of 68. So if we did the square root of 17 plus the square root of 68, that's the square root of 85. And we're going to divide that by 2. That's about 4.6. So that should be our distance here. So if we're trying to do the distance formula, you could also use it that way. So I I think the best way to do it is, actually you could use either way, but if you look at your graph, it has to be between 10 and 12. It does look like it's halfway between 10 and 11. So they've estimated it at about 10.5. So if you have something around 10.5, that would be the best way to determine it. The next problem we're going to do is related to kites. So we had two theorems related to kites. If we go back to the beginning. If a quadrilateral is a kite, then its diagonals are perpendicular. And then if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So we're going to use those theorems, keep those in mind. And we have a kite. And here's my kite. So it tells me that the diagonals are perpendicular. It tells me that the sides, the top sides are congruent and the bottom sides are congruent. So if we have BAD is 38, which is here, and BCD as 50, we need to find ADC. So if we use that as an entire triangle on the left side, we would have to add up 38 plus 50 equals, or plus x, equals 180. And then we can use that same x on the other side. So 88 plus x equals 180. Solve for x. So x would be 92, which makes the measure of angle ADC, excuse me. Okay, I thought this was wrong. I didn't label it correctly. BAD is 38, so that's this whole thing. Whole thing is BAD. And then BCD, same thing. It's the whole top is 50. So those two, 38 and 50, are not equal. So that makes the other side have to be equal. So we know that a quadrilateral adds up to be 360. So we want to do it that way. So 38 plus 50 plus x, because these two are going to be the same, equals 360. We solve. So that's 88 plus 2x equals 360. Gives us 272 equals 2x. And then we divide by 2, so that's going to give us x is 136, which is the answer. And the last one, BT is 5. T is in the middle here. BT is 5 and TC is 5. So that's this side and this side are both 5. And that's a right triangle. So if we're trying to come up with the other side, or no, TC is 8, sorry. BT is 5. So we have a right triangle there. We can use the Pythagorean theorem. So 5 squared plus 8 squared equals c squared to get CD, because that's, even though it's on the other side here, it can be the same as this side because it's indicated as the same. So we're going to do 25 plus 64 equals c squared. and that's 89. And then we have 89 equals c squared, so to get c by itself, we're going to take the square root. So c is going to be the square root of 89. And that concludes lesson 6-6.